Hello everyone, I am Atharv Naik and I am from the Cambridge International School, Dubai. Let's talk about everything. The universe, the Milky Way, the solar system, a little blue planet called the Earth, we humans. If we go smaller, we find molecules, even smaller particles called atoms.
There are two types of particles, elementary and composite. Composite particles can be split into more particles, whereas elementary particles cannot be split into more particles.
Atoms are made up of even smaller particles called electrons, protons, and neutrons. Then we have the quarks, leptons, and the gauge bosons, which are force carriers. And there you have it, the elementary particles. These give mass to everything. But if these give mass to everything, what gives mass to these? And that's the million-dollar question, quite literally.
So our friends at CERN decided to build a large hadron collider to smash particles and see what they find.
Presenting the Higgs field.
First proposed by a British physicist named Peter Higgs.
The internet definition over here is rather hard to understand and overly complex. So let's simplify it. Suppose there's a room filled with news reporters. A student enters and wants to reach the opposite corner of the room. He gets to his destination without being stopped by anyone. Why is this? Because no one cares about the student and the student doesn't interact with the people. Thus, the student is allowed to pass freely. So here, the student is a particle which does not interact with the field and has low mass or is massless. A photon would be a good example. The president of the country enters and wants to reach the same place, except he's blocked by the reporters. The president interacts with the news reporters and is slowed down on the path to his destination. The president, representing a particle, interacts with the field and has mass. A good example would be a top quark. So we've got the field, now we get the Higgs boson. Another reporter enters the room and decides to have some fun. He spreads a juicy rumor to his nearest reporters. The rumor spreads to every person in the room. Over here, the rumor represents the ripple or excitement in the field of people. Once we relate this to the Higgs field, the ripple over here is the Higgs boson, created by providing enough energy, which is the news rumor. So there we have it. Mass works by different particles interacting differently with the Higgs field. The Higgs field is also a non-zero field, which means that the Higgs field has a uniform distribution over the entire universe. It also has a non-zero point energy, which means it's never at rest. We know the Higgs field works, but what we don't know yet is why exactly does it work.
This is a pencil.
Nature tends towards the lowest energy state. If we hold a pencil above ground and drop it, it converts its gravitational potential energy into kinetic energy. The same way the Higgs field converts its ground state energy and gives the particle mass. What does it mean to break symmetry? Symmetry is the property of a system that remains unchanged after transformation. So if we violate a symmetry, a reaction occurs. In this case, the Higgs mechanism. Does the Higgs boson have a mass of itself?
The Higgs field gives other particles mass, but does it have a mass of
Yes,
itself?
it does. It has a mass of about 125 giga-electron-volts, and that's a lot. The Higgs boson has quite a short life.
Which relates to our rumor analogy, because no one will care about the rumor after a while.
The Higgs boson has a very short life. Some misconceptions. The Higgs boson itself does not give mass to the elementary particles. The Higgs field does. The Higgs boson is just a ripple in the Higgs field. Second, the Higgs mechanism does not account for the mass of everything. Most mass comes from the energy in the gluon field between quarks, which are called flux tubes. And according to E equals mc square, the energy relates to most of the mass. Why is the Higgs field so important? If not for the Higgs mechanism, there would be nothing other than a bunch of elementary particles whizzing around at the speed of light. Absolutely nothing.
No stars, no galaxies, no anything that we see here. A boring universe.
So thanks Higgs for everything, and thank you for watching.